Clinkerization is the technical term for clinker production. Clinker is the main and essential ingredient in cement. If it's attracting a lot of attention recently, it's because the cement industry is responsible for almost 8% of global CO2 emissions. That's according to the Global Cement and Concrete Association. And most emissions occur during the clinkerization process. Coming up with new ingredients for clinker, and therefore cement, and how it is made are crucial for building more sustainably.
So more concretely, what does this term clinkerization actually mean?
And how is this concept driving change in the construction industry? I'm James.
And I'm Amy. Together, let's decode the ideas that are shaping the future of sustainable construction.
Constructing New Worlds by Saint-Gobain. Behind words, solutions, and innovations for a sustainable future.
To construct buildings, bridges, and tunnels, you almost couldn't do it without using concrete. And the main ingredient of concrete is cement. Concrete is made from fine powdered cement, aggregates, and sand mixed with water. Cement contains clinker, which is produced via the process of clinkerization at very high temperatures. To be more precise, it's a physical and chemical process in which raw materials are heated in a kiln to temperatures surpassing 1,400 degrees Celsius. So, as you can imagine, the process is energy intensive, to say the least. And not to mention high carbon emitting.
How come?
Well, because the principal materials heated up are limestone and clay, which are both natural and non-renewable. The ingredients are first crushed and washed until a uniform powder is obtained, called raw meal. This powder is then cooked to produce clinker. However, during clinkerization, carbon is extracted from the limestone and carbon dioxide is released.
So, what's the answer? We'll always need concrete, which means we'll always need cement, right?
Right, especially considering that few alternative materials can outdo concrete in terms of resistance, especially for constructing enormous industrial facilities or huge structures, and that housing is a top global priority given the soaring population. Plus, you have to keep in mind that concrete is a low-cost material, so highly competitive. The entire value chain from cement and concrete producers to construction firms are well aware of the environmental footprint of concrete. They are therefore working on developing solutions to build more sustainably. So action is needed to ease the strain on natural resources and reduce the use of clinker.
Exactly. And there lies the key, Amy, changing the composition of clinker and cement in the first place. We also need to take the entire production process back to the drawing board to make it just as energy efficient. Nowadays, we're seeing the development of cements which contain less clinker.
How are they doing that?
Well, solutions also exist to reduce the need for clinker altogether, or at least partially. For instance, using rice husk ash, fly ash, slag, which is a byproduct from the metal industry, and even volcanic ash. Alternatives which all show interesting properties when added to cement and reduce the carbon footprint of clinker production itself.
But what about concrete, James?
Well, in terms of concrete, aggregates can be replaced with hemp, a bio-based material, and cement with soil. The problem is that when it comes to construction, fast and fairly cheap tend to win out the day. Producing biomaterials, however, is often a much more complex and lengthy process, seriously delaying construction timelines. Concrete producers are looking to the field of chemistry to improve their sustainability credentials. For example, admixtures are being added during concrete mixing, ergo superplasticizers, to reduce the amount of cement needed and therefore its carbon footprint. Hence, all the interest in construction chemicals.
So we're talking about sustainable chemistry?
Exactly. Innovation in cement composition is one of the best opportunities we have to make the construction industry more sustainable. Innovation means finding the right materials and the right formula. It goes without saying that concrete has to tick all the boxes performance-wise.
So have we found any?
Well, yeah, research currently underway is creating more innovative admixtures that are helping to cut the amount of clinker used. Did you know that a low-carbon, zero-clinker cement has already been developed that can cut our carbon footprint by 5? And by extension, shrink an entire building's carbon footprint. Everyone's a winner.
Yeah, and I believe there are other solutions available at different stages of cement's life cycle. For instance, using waste, right?
Yeah, you're totally right, Amy. Some cement manufacturers are working with waste facilities to source alternative fuels, which can be incinerated to recover energy. This reduces the use of fossil fuels like gas, oil, and coal. This material is called refuse-derived fuel, or RDF. It's a small but important way to shrink clinkerization's environmental impact.
But that alone won't cut it?
No, certainly not. It takes a huge amount of energy to burn the waste, huge quantities of which are needed. In the interests of sustainability, we should be reducing waste, so cement producers don't really want to rely on this type of fuel in the long term. Let's be realistic. The construction industry isn't going to be saying goodbye to cement or concrete anytime soon. Their qualities have been proven over millennia. But progress in engineering, along with the innovation in construction chemicals and calls to decarbonize the construction industry, are paving the way to greener concretes.
Yeah, it's crazy to think that some buildings made of concrete have been standing for hundreds and even thousands of years. Materials don't get much more durable than that.
Constructing New Worlds by Saint-Gobain.
Behind words, solutions, and innovations for a sustainable future.